Example 2, writing an equation for an absolute value function given a graph. So we want to write an equation for the function graphed here. Okay. Now, what we need to do is we need to write down what is the form for an absolute value function. Well, we know that f of x is equal to a, and that a represents a vertical or horizontal stretch factor, times the absolute value of x plus c, where c tells us whether we shift left or right, plus d, which tells us we either shift up or down. So we need to take information from this graph in order to then figure out what we need to do next. Now, the basic absolute value function changes direction at the origin. So this graph has been shifted to the right 3 units and down 2 units. And the way we can figure that out is by looking at the ordered pair. And that's the ordered pair located right here. We can see that the x coordinate is 3 and the y value is -2. So that tells us that we've shifted the graph over 3 units, so that's x minus 3, and then we've gone down 2 units. So we can plug that into our function. So we have f of x, which is equal to a, times the absolute value of x minus 3 minus 2. Now, we need to solve for a. So in order for us to be able to solve for a, we need a point on the graph, another point on the graph from the shift. So if you look up here, there's a nice point here that we can use on the graph, which is 1, 2. And you can see how we figured out that point from here. So here we have the point 1, 2. And so we know that x is going to equal 1 and the value of y is 2. But recall that y is also f of x. So in our form, what we can do in order to isolate and solve for a, we're going to let f of x equal the value of 2. We're still looking for a. And we can let x equal 1 according to that coordinate. And then we're just going to go ahead and use order of operations. So we take 1 minus 3, which gives us -2. And so then we can add 2 to both sides to get 4. And the absolute value of -2 is 2 times a. And now if we divide both sides by 2, a is going to equal 2. So from this information, we can then now write a to be 2. So now we have the function f of x, which is equal to 2 times the absolute value of x minus 3 minus 2, treating the stretch as a vertical stretch. Now, question and answers is, do the graphs of absolute value functions always intersect the vertical axis or the horizontal axis? Well, yes, they always intersect the vertical axis. The graph of an absolute value function will intersect the vertical axis when the input is 0. Now, no, they do not always intersect the horizontal axis. The graph may or may not intersect the horizontal axis, depending on how the graph has been shifted and reflected. It is possible for the absolute value function to intersect the horizontal axis at 0, 1, or 2 points. So you can see here, it doesn't intersect it, only the y on the y-axis. Over here, it intersects it at 1 point on the x-axis and the y-axis. And then here, it intersects the x-axis twice, where it crosses the y-axis once.